Comparison of two cancer risk models, using statistical methods and viscoplastic energy model. Number 1218, VMT Sharp 694, February 3, 2025. By Gerald C. Shu, EclaireMD Foundation. Category Oncology. Abstract. Key message. Recently, the author has further refined his cancer risk prediction model. He then compared this new cancer risk percentages against 5 influential factors: visceral fat, weight, fasting glucose, daily averaged glucose, and quarterly lipid levels to calculate their interaction energy level. First, he applied various statistical tools to uncover some hidden relationships among his collected data over a period from 2015 to 2025. In statistical analysis, he identified glucose as the most influential factor, impacting his cancer risk. His viscoplastic energy analysis (VMT) also quantified the contributions of each factor as follows: glucose 41%, visceral fat 26%, weight 20%, lipids 13%. His new cancer model's total VMT energy 83 is 79% of his old cancer model's energy 105. This reduction reflects the depth and width of inclusion of 4 foundation factors: genetics, environmental, carcinogens, and inflammation, which were readjusted in the new cancer risk model based on epidemiology studies. Description: using the ChatGPT AI tool, he conducted various statistical analysis, and included the results in the biomedicine section of the main article. 2,194 words. The main statistical findings are: glucose and inflammation (CRP) are the primary drivers of his cancer risk. Visceral fat has a greater influence on cancer risk than overall body weight, while lipid levels have minimal impact. Oxidative stress and gut microbiome may play some indirect roles, but their correlation with cancer appears weaker in his case. Influential factors in cancer risk, categorized into 3 major groups: 4 foundation factors 60%, genetics, environmental exposure, carcinogens, inflammation; 4 biomarkers 20%, body weight, glucose, blood pressure, blood lipids; 6 lifestyle factors 20%, food portion, diet quality, hydration, exercise, sleep, stress. Using 10+ years of personal health data, the model has demonstrated some extra findings validated by the viscoplastic energy model (VMT). Among those 4 biomarkers, blood glucose, hyperglycemia and insulin resistance, and body weight, obesity and excess fat around belly, are the strongest cancer risk drivers. High glucose and diabetes are linked to pancreatic, colorectal, breast, liver, and endometrial cancers. Obesity is associated with 13+ types of cancer, including colorectal, kidney, liver, pancreatic, and postmenopausal breast cancer. The author has no significant genetic influence or major environmental exposure to cancer risks. He has never smoked, consumed alcohol, or used illicit drugs, and has been medication-free since 2015, successfully managing diabetes through lifestyle interventions alone. His old cancer model distributed higher weighting loads across biomarkers and lifestyle factors, because it excluded most of the 60% contribution from the foundational factors. Consequently, the relative impact of each remaining factor was greater in the old model. However, in his new cancer risk model, the total weighting contribution of biomarkers and lifestyle factors is set at 40%, making the relative impact of each individual contributor in the new model lighter compared to the old model. In summary, over the past decade, the author has collected millions of data points on his biomarkers and lifestyle factors, allowing him to calculate his daily cancer risk study with high accuracy. The author listed his new cancer risk prediction equations as follows. Summary of differences noticed by the author. 1. Statistical correlations between 2 predicted cancer risk models. All 4 weight and glucose biomarkers show strong correlations from 66% to 95% with his cancer risk, while lipids exhibit very low correlations from 2% to 36%, likely due to the limited availability of quarterly lipid data. However, the averaged value difference is 18%, cancer risk ratio 32.9% divide 40.1% is 0.82, primarily due to the old model, heavily focusing on biomarkers and lifestyle factors, which accounted for 40% of cancer risks. 2. Comparison of total VMT energy. The VMT interaction energy ratio between the new and old cancer models is new 83 divide old 105 is 0.79. Again, this VMT energy difference is attributed to the old model, heavily focusing on both biomarkers and lifestyles, and including only part of foundation factors contributing 60% to CKD risk. 3. VMT space diagram analysis. These 2 VMT space diagrams comparing the old and new cancer models indicate that the old cancer risk curves are positioned further to the right, indicating higher horizontal strain. This is due to the higher strain, cancer risk, change rate over time associated with the old cancer model.